Mentioned in the previous video that the distance of 1 parsec is basically defined by stellar parallax. Now, you're probably familiar with the term parallax being an error in measurement if you're not looking at the scale straight on or perpendicular. If you're looking at it sort of to the side, and so the measurement appears smaller or larger than it should. Stellar parallax is essentially the same sort of idea, and it's basically looking at the fact that the apparent movement of a nearby star, and by nearby we just mean one that is closer to us compared to some other stars, and these nearby stars appear to move, and they appear to move against the distant background stars. Now, when we're talking distant background stars, what we're really meaning is that there are stars that are out there that are so far away from us that even our movement around the sun doesn't have an effect on where they appear in the night sky. They always appear to be in the same position, but some other stars that are closer to us appear to sort of move backwards and forwards as the Earth moves around the sun over the course of a year. So we're not talking about sort of what happens at night, in one night. We're talking about as the sun moves over the course of a year. Now, to try and demonstrate that in a little bit more detail, I'll sort of sketch a bit of a diagram here. So we're going to start out with the sun positioned here, and we'll have the Earth, say, here to begin with. So this represents the Earth, and at that point in time it's going to be, we'll refer to that as being, say, January. And we're looking at a star that's positioned somewhere out here. And now we'd have some background stars that would be positioned a lot further away. So they're basically just our reference point. So this is the star that we're interested in, and these are the background stars. Now, with the Earth in that position there, if we were to draw a straight line, I'll use a straight line here so I don't mess it up. If we were to draw a line passing from the Earth, so this sort of line of sight, that star would appear to be sort of positioned somewhere over here. So as we look at it from Earth, the position of that star would be sort of to the right of these this grouping of background stars. Now, if we were to measure the angle that from the middle of the sun through that star, so imagine, say, a quarter of the year through, so the angle between those two lines here is the value P. That would be referred to as the parallax angle. So there's our parallax angle there. Now, as the Earth, across the course of the year, it's going to move around the sun, and so at some 6 months later, so the Earth now being in July, the position of the star now would appear to be further over to the left of that grouping of stars. Now, in that orientation, that's still going to be the same angle P there, so it's still the same parallax angle. The distance that the Earth has then travelled across, or sort of, if we sort of subtend that angle, so in other words, if we join those two lines across here, that would give us our baseline that we're making our measurement against. And that baseline, as you can see, because we're dealing with the position of the Earth having moved from one side across the other, the distance from the Earth to the Sun is 1 astronomical unit, so that baseline is 2 astronomical units. And so if we look at the distance across the baseline there, and we know what the angle is that's subtended at the top of this triangle, then we can figure out what this distance here is, that distance D. So that's the distance to the star, so that length there. So that being the distance to the star, we can then calculate that distance. The equation for that is really quite straightforward. So it's D measured in parsecs. So this wouldn't usually write the units in here, but this is the way that it's formatted in the data booklet. That's equal to 1 over the parallax angle measured in arc seconds. So the brackets there just simply to indicate the units of measurement of the quantities there, so distance in parsecs and p in arc seconds. So there's the equation that we can use. So going back to that definition of the parsec, if that angle is 1 arc second, if the parallax angle is 1 arc second, then that will give us a distance of 1 parsec, where the baseline would still be 2 astronomical units, but then half of that would be 1 astronomical unit. So, like I said, a little bit of a convoluted definition if you're not quite sure what the terms mean, but hopefully that makes a bit more sense now and gives you a bit of an understanding what parsecs actually mean. Now, there are some limitations to this particular method, and that basically comes down to a few environmental factors. So parallax angles of less than 0.01 arc seconds. Now you might sort of think, well, hang on, that's a ridiculously small angle considering that 1 arc second is 1/3600th of a degree. When you're talking about very large distances, those angles are still quite easy to measure considering we've got the background stars to measure against. So they are difficult to measure or to resolve, more to the point. So if we're looking at trying to identify the movement of a star against the background stars, difficult to resolve angles less than that from Earth due to the atmosphere. So a couple of the problems that we get there being the absorption of the atmosphere, so it's going to absorb some light that's being radiated from stars. Scattering of light through the atmosphere is also a problem, so it decreases the brightness of stars, makes it difficult to sort of locate their position, and the last one being turbulence, which causes stars to twinkle. So if we get that twinkling of stars, that's going to make it hard to identify the exact position of the star and to measure the angle accurately. All of that combined limits distance measurements to 100 parsecs. So because of the atmosphere, it makes it a bit difficult to get some really detailed measurements. However, there is a satellite or a telescope that's in orbit around the Earth. It's been orbiting Earth since about 2013, I think it is. And because it's orbiting Earth, it's outside Earth's atmosphere, it can resolve angles to 10 micro arc seconds. So to put that into context, that's 0.000010 arc seconds. So very, very small angles, and that means that it can measure stars that are a fair bit further away. Being up to 100,000 parsecs away. So there's stellar parallax. Some of the important things to note there about the difficulties of stellar parallax to measure distances. So the limitations being that it can only measure up to 100 parsecs from Earth. As we move forward now, we'll start looking at the brightness of stars and some of the other attributes as well.